Another section we would cover in class is section 5, which covers other types of equations. There's quite a few types of equations in this section. Specifically, we're going to talk about polynomial equations, which linear and quadratic are really a subset of polynomial equations, equations containing radicals, equations containing rational exponents, and lastly, equations that are quadratic in form. The official definition of a polynomial equation is an equation of the form a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus all the way down to a sub 1x plus a sub 0 equals 0, where the expression that's on the opposite side from 0 is just a polynomial of degree n. So remember, that means we're just going to add terms like 5x cubed or negative 4x to the fifth. Things that have whole number exponents, coefficients are just real numbers. The degree n of the polynomial indicates the number of solutions of the equation, including repetitions. We've seen that with quadratic, right? A quadratic had degree 2. There were 2 solutions. A linear equation had a degree 1, and there was 1 solution, except for those special cases of contradictions and identities. So the degree n, here are some specific examples of what I was just talking about. Like a linear equation, 3x minus 9 equals 0. It has 1 solution. X squared minus 9 equals 0. We can solve that by the square root property to see that there are 2 solutions. And here's one, x cubed minus 9x equals 0. There we factor out a common factor of an x. That leaves x squared minus 9 equals 0. So the x can equal 0, or the x squared minus 9 can equal 0. And so you can see that we get the 3 solutions of 0, 3, and negative 3. So the way we're going to solve polynomial equations is actually the way we did quadratic, by the zero products property. That is, we're going to set one side equal to 0, and then we will factor the polynomial until all factors are linear or quadratic. Then we'll apply the zero products property by setting each factor equal to 0 and solve the resulting equations. All of the polynomial equations we will work in this course will be factorable. There are some that are not, but that's beyond the scope of what we cover in this particular course. Let's look at some illustrations then. First example is 4x cubed equals 100x. We notice that this has a degree 3, so we would expect 3 solutions. We will find those 3 solutions by setting this equation equal to 0 and factoring. We will subtract 100x from each side to get 4x cubed minus 100x equals 0. Now we have to put on our factoring hat and think about how can we factor this. First, notice that there is a common factor of 4x. If we divide each term by 4x, that leaves x squared minus 25, and then equals 0. Now, if you want to factor this further, we can. X squared minus 25 is the difference of 2 squares. So that factors as x minus 5 times x plus 5. Now, when I say the equations are going to be factorable, they will initially be factorable. It could be that you get something after you factor that has a quadratic expression that you can't factor any further, and there you might have to use completing the square or the quadratic formula to go further, or the square root property. But here we set each of the factors equal to 0 to get 4x equals 0, or x minus 5 equals 0, or x plus 5 equals 0. So our solutions are, if we divide the first equation by 4, we get 0. We can add 5 to get x equals 5, or subtract 5 to get negative 5. So our solutions are negative 5, 0, 5. Remember that we write our solutions in order from smallest to largest. We separate them by a comma. In Top Hat, you want to do that, but you don't want to put any spaces between the solutions because it doesn't read the spaces correctly. Part B is 2x cubed plus x squared minus 18x minus 9 equals 0. This is a polynomial of degree 3, so we would expect 3 solutions. We have 4 terms, so we're going to use factoring by grouping to get these equations solved. We're going to group together the first 2 and the last 2. So between 2x cubed and x squared, there's an x squared in common. Dividing out, we are left with 2x plus 1. Now be careful here, between negative 18x and negative 9, if the middle sign is negative, we need to factor out a negative 9, which is our common factor. Negative 18x divided by negative 9 is 2x. Negative 9 divided by negative 9 is plus 1. Remember, with grouping, our goal is that we should get a common binomial to factor out. So 2x plus 1 is that common binomial times x squared minus 9 equals 0. Now we could factor that further. I'm going to show you an alternate way to solve this. We could stop once we get a quadratic or linear factor, set each of those to 0. So I'm going to set 2x plus 1 equals 0, or x squared minus 9 equals 0. Solving the first equation, we get 2x equals negative 1, or x is negative 1/2. X squared minus 9 equals 0 can be solved by the square root property. We can set x squared equal to 9, and then apply the square root property to get x equals plus or minus the square root of 9, which is plus or minus 3. So our 3 solutions, the smallest of those is negative 3, then negative 1/2, and positive 3. So an important theorem to remember is the factor theorem, and it states that if x minus r is a factor of a polynomial equation, then x equals r is a solution of the equation. And remember, that comes from the zero products property, right? If you have x minus r as one of those factors, whatever these are, we have to set x minus r equal to 0. So therefore, x equals r is a solution. The next type of equation we're going to solve is equations containing radicals. Mostly we're going to look at equations that contain square roots. And so, first of all, defining it, a radical equation is an equation that contains one or more radicals with variables. The goal in solving a radical equation is to clear radicals from the equation. Now, when we clear radicals from an equation, we're going to have to raise each side to an equivalent power, right? Do you remember this fact that if I had, for instance, the square root of 25 and I square it, the square root of 25 is 5, but 5 squared is 25. So the thing that will undo the square root is squaring. So if I have an equation of the form, let's just say x equals b, then what I'm going to have to do is raise each side to the same power to get rid of the radical. So I would get something in the form x squared equals b squared. Well, this is very similar to rational equations. In doing that, I may introduce extraneous solutions that I have to check. So we will isolate the radical to one side. If there's more than one radical, have one radical on each side of the equation. Raise each side of the equation to an exponent equal to that of the index of the radical. Solve the resulting equation. And if it still contains a radical, repeat the steps, and then you're going to check the possible solutions. Here's an example. We have the square root of 3x plus 1 equals 11. So the variable expression is on a side by itself inside that radical. So to get out of the radical, we have to undo the square root, which is to square. The square of the square root of 3x plus 1 is just 3x plus 1. 11 squared is 121. So we can subtract 1 to get that 3x equals 120 and divide by 3 to get 40. Now we think 40 is the right answer. We do have to check it. It definitely solves that equation that results after the radical is gone. The square root of 3 times 40 plus 1, does that equal 11? And yes, that's 120 plus 1, which is the square root of 121, which does equal 11. So our solution is 40. The equation square root of x plus 12 equals x minus 8. Notice I have variables on each side, but I have to get the radical on one side. So that's the way I need it. Now I have to perform something that will remove the radical, which is to square each side. When I square the square root, I just get x plus 12. And be very careful here. When I square x minus 8, I really have to multiply it by itself and distribute to get x squared minus 8x minus 8x plus 64, which is x squared minus 16x plus 64. Remember, I get a perfect square trinomial when I square a binomial. This is a quadratic equation. I need to set one side equal to 0. Since my square is on my right, I'm going to subtract x and subtract 12. That gives us the equivalent equation, 0 equals x squared minus 17x plus, what is that, 52? And so now I need to find the factors of 52, whose sum is 17. So what is that going to be? 13 and 4? Yes. And I know they have to both be the same. They both have to be negative. So we have that x minus 13 is equal to 0, or x minus 4 is equal to 0. So our solutions are either 13 or 4. Looks lovely, looks like we could be done, but we're not. We have to go back and check, because these are the solutions of the quadratic, but not necessarily the original. So when I plug in the 13, I'm asking myself, is 13 plus 12 inside the square root the same thing as 13 minus 8? That's the square root of 25 on the left. Does that equal 5? Yes. If I plug in 4, I get the square root of 4 plus 12. Is that equal 4 minus 8? The square root of 4 plus 12 is the square root of 16. Does that equal negative 4? No, because the square root of 16 is positive 4, not negative 4. So 4 is an extraneous solution. We have to discard it. And our only solution is 13.